right, guys, hopefully have a good video for you today. I know it's been a while. My sincere apologies. A lot of stuff going on with work, and I got diagnosed with cancer and all kinds of crazy stuff going on. So yeah, you did hear correctly there. Think I'm doing all right here. I had surgery a couple weeks ago to remove a tumor, and then we've got to do some testing to see that things haven't spread around and got all nasty and all that. So anyway, just wanted to have a good excuse for why I haven't produced a video. I think that counts. All right, what we're gonna do today is we've got this 1999 Olds Cutlass right over here. So this is one of those barnyard kind of finds here. This is a 1999 Olds Cutlass GL with only 92,000 miles on it. Yes, it is owned by the little old lady that only drives it to the Piggly Wiggly. This is owned by, I think she's 84 years old. And when I met her in person at her ranch, not too far away from here, she was baling hay out of her pickup truck to feed her horses. That kind of lady, holy crap. And she's like all of maybe 5'5", but holy cow, she is a ball of fire. So anyway, so we're going to look at three issues with the car, two of them of interest to us. One of them, it has a fairly annoying belt squeal, especially when the engine is cold. It is clearly a tension issue. The belt is really glazed over, so we're going to replace the belt, and I believe I'll also replace the tensioner as well, and that, of course, we won't cover on this channel. We also have a issue where the speedometer does not work. It pretty much just stays buried at 0 all the time. Occasionally it'll make little erratic jumps up to like 120 miles an hour. Knowing this lady, it is possible because she is going that fast. But clearly the speedometer does not work. There is a code on the computer the lady gave to me. It was I think a P0502. I'm pretty sure this is going to come down to a vehicle speed sensor, but we'll have to check that. And then the other thing is we've got a check engine light for a P0341 camshaft position sensor performance code. So we'll take a look at that as well, but I can tell you the engine runs totally fine here. So her main concern really actually is the belt squeal of all things. But let's go ahead and plug the scan tool in, take a look at some data, and see what we can do to diagnose and figure this out. All right, let's get a look here. You can see we've got, all right about there should work. And you can see P0341 camshaft position sensor performance and a P0502 vehicle speed sensor circuit low input. So circuit low input, this means we've probably got some type of short in the system, possibly even short to ground. More likely a bad sensor that is shorted, I would say. So let's do this. The first thing we want to do, I can tell you I drove the car around the block. The speedometer was just buried at 0. This is a front wheel drive car. We could just lift the car up, put it into drive, and show that the wheel speed sensors are working and will record an input, but the vehicle speed sensor most likely is not. We could do that. We could also start with the camshaft position sensor. Let's see, these are two completely separate independent issues, so it really is a matter of preference which we do first. Really, I'm not supposed to be crawling around under the car quite yet and stuff, so maybe we will start with the camshaft position sensor first and then see what is involved with this VSS. I believe that the VSS is going to be underneath the car on the transmission, and I would have to crawl under the car, and I would rather not do that. We'll see if we can come up with an easier way perhaps. So let's start off with this P0341. All right, let's see. Oh, we've got the 3100 in here. I haven't seen one of these in a while. So one thing I'm sure many of you guys are aware, let's get you a look here, that should look familiar to probably quite a few of you, and I do know enough about this engine that I am familiar. I used to, years ago, do a lot of intake manifold gasket replacements on these. And as a matter of fact, I'm pretty sure I've got at least a couple videos on that. But they've got these wet intake manifolds on the lower that will leak coolant. Almost every one of these engines has done this at some point in its lifetime. And then even replacing the gaskets doesn't fix it. And the big problem is it leaks coolant internally, not externally, internally, which of course means you dilute your oil with coolant and it can destroy the engine. And a number of these cars have had this issue. You've got to buy a really good aftermarket gasket because the GM gasket seems to have a design failure where even replacing the gasket with the GM part pretty soon after the problem happens again. So if you haven't been aware of that, now you are. All right, what we want to do here is start off with this camshaft position sensor thing. So let me grab my scan tool. Let's just see if we can get some data. And I also, this is going to kind of suck because I know that this has a really bad belt squeal. So we may have to work through that, or I may just remove the belt possibly even. Okay, so you can see the car starts right up immediately. And that does not always happen according to the lady. She says sometimes it will take a long crank time for it to start. Very typical of a cam or crankshaft position sensor issue. Let's go ahead and focus on our scan tool here. All right, don't hear any misfires or anything going on right now. No, I don't want to quit. I want to go in here and just see what we have available on this 26-year-old car. Let's go to engine data display. Whoa, we also had transmission data display. We could probably look at the VSS there. Right now we're going to focus on, well, there's camshaft position sensor signal data. Let's see what we got here. 24x crank sensor. We're going to do, I wanted engine RPM on here. I'm going to take this vehicle speed, by the way, just because I've got the car lifted and we will go ahead and check that VSS real quick. See if there's any VSS input. Maybe it's a bad speedometer and we would have VSS input, but it just wouldn't show on the analog speedometer. Ignition, I wonder if that would give our timing. That might just be ignition voltage. Not sure, but it looks like this may be all we have. Oh, engine speed, of course I need that. Okay, let's just go with that. Oh my God, this is slow. It's going to be really slow. All right, I'll come back after this loads. Well, we can see that we do have a camshaft sensor signal present. Looks like this was ignition voltage here. I'm not really worried about that. This car's got 92,000 miles. I'm very positive this has a timing chain on it. I'm not worried about a timing problem. I'm worried about a signal problem on this for this camshaft position sensor. Looks like we also have our crank sensor working, of course. So we are probably going to have to put a scope on this to see what's going on with this camshaft signal. I think that'll be the easiest way to do it. I'll have to find where this sensor is. Right now, I think the next easiest thing, well, let's go back here and let's just look at this vehicle speed sensor thing because we have transmission data display right here. And transmission data, what I want to do is I want to pull up vehicle speed, and it looks like we don't have wheel speed sensors on here. So we will have to go back out of here. All right, that may be on the chassis actually. Let's read our data stream here. Yes, that would be what we want. Okay, so what I wanted to get here is well, we're not going to do rear wheel speeds because the vehicle is lifted and it's a front wheel drive. You know what? We can manually turn those wheels too, though. So we'll get left front, left rear, right front, right rear, and vehicle speed. That's all we want there. Okay. So what we're going to do is let's check our wheel speed sensors first. I am sure this is not an issue where all 4 wheel speed sensors are dead, but it's possible that we could have some kind of module issue or something here. So let's go back to one of these rear wheels. All right, let's see if we can prop this scan tool up here. All right, I'm here at the left rear right here. We're gonna spin this wheel and you can see that the wheel speed sensor works. Just gonna go ahead and do this on the other side off camera, verify that that works as well. All right, both rear wheel speed sensors work. What we're gonna do now is put this car into drive here. We're gonna look at our front speed sensors here. We see that they work. Oh, there's the belt squeal when I speed up a little. So we see we've got our front wheel speed sensors working, no vehicle speed and no speedometer. See our tach on the left going up. We are in drive. No speedometer. Okay, this looks like a bad VSS to me. All right, obviously, replacing the cam and VSS sensors on a guess. Ooh, is that a VSS sensor back there on the transmission? I do believe I see the VSS actually just kind of by accident here. And that would be underneath the vehicle. I think we're gonna go ahead and go for that because it's super easy to access if that's it. But what I need is this camshaft position sensor. And I'm not quite sure. Oh, is that it right there? That may be it right there under the power steering pump. That is a bummer of a location. Let me check. Sometimes these are on the back. There is a coolant temperature sensor there. I do not see. I'm pretty sure that's it. Wow, what a bummer of a location, honestly. I am pretty sure it is a 3-wire sensor buried under. We would have to remove the power steering pump to get to it. Now, there is a wire coming up from here, a cable. Hold on a second. So we got a cable coming up from it right here, and that I can tap into. And as a matter of fact, look at this. That cable goes right to this connector. All these connectors are just floating around here. I guess a lot of work's been done on this car before, but right there is our connector for this, what is obviously a camshaft position sensor here. So if that's the case, let's see here. We have a Hall effect sensor, and it looks like down here, this is clearly a connector for a crankshaft position sensor right behind the water pump that I can easily access. All right, I think what I want to do is I just want to be thorough on this. I am 99% positive there's our camshaft sensor connector. I'm also equally positive, actually I'm 100% positive that that is a crankshaft position sensor because I can see it where it's going to. Yeah, that is going right behind the crank pulley. All right, so let's pull up a wire diagram real quick, and I just want to be 100%. Yeah, you know what? We don't need a wire diagram. We're gonna see this on the scope clearly. I don't think I need a wire diagram. Can we do this just by looking at the scope signal? Yes, sir. Yes, I can. Yes, I can, sir. All right, I think we're gonna go ahead and set up for 2 channels here. We don't really need it, but I just wanna see that crank sensor just to be sure. All right, set up the PC here. And the reason we're using the scope is because it says that it detected a camshaft signal. So that means if we were to try to use a DVOM, we would not be able to make any kind of determination whatsoever. We have to see the actual amplitude of the signal, and if there's dropouts on the signal, cannot do that with a DVOM. All right, let's go here. I got my computer fixed up where I am now able to finally run Picoscope 7. A lot of you guys were wondering why I have not done that. It's because there's a graphics card incompatibility with the Picoscope software, but I was able to get a patch from somewhere that has fixed that. So basically what I did is I just disabled the hardware acceleration and now it works. All right, we are going to pull 2 channels here. Let's jump up maybe to about 0.5 millisecond per division as a starting point here. And I think channel A, We're going to do my typical trick to look for any dropouts or anything, where we are going to probe. Look how easy this is. Connector right here. This is so unbelievably awesome. So let's see, we've got a red, a green, and a black. I am going to take a guess that the black is going to be our ground, and the green is going to be our signal, and the red will be a reference. So let's just check that real quick. One of the things I need the key on. Okay, key on, and we see we jump up to 12 volts there. So this has a 12 volt reference, not a 5 volt. Many cars do have that. That means that because my polarity is correct, that I have guessed my wire is exactly correctly. And that means this green wire in the middle here is going to be our signal input. And now that I think about it, I did a video a while ago where maybe the green was the reference. So we just need to run the car and find out. Now I'm not totally sure. I just know I'm on a ground correctly. Not sure if I'm on signal or reference right now. So I thought on my old Trans Am the green was the reference. Well, I am definitely on a signal here. So let's move that to the red wire, and that's going to be a constant 12 volt. It is. Not crazy about all the noise on the signal there, but one of the problems is that they've got this wiring running right along the ignition coil, which is a terrible idea. I'm going to try to move that away from there. All right, and let's get a close look up on the screen here. Okay, we are on what I believe is going to be the camshaft signal here. Let's just verify that real quick. Increase RPM. Yep, most definitely. You can really hear that annoying belt. We'll just deal with that. Okay, so let's zoom into this a little bit more. Now we're going to need a trigger on here. Perfect, right there. Okay, so looks to me like a pretty good signal. Now what I want to do is, I think I want to go ahead and pull in my crankshaft signal just to take a look at it. So now I need to back probe. I wonder if I can piggyback off the ground off of this signal. I'll bet I can. All right, probably can't see anything, but the crank sensor connector is right under the water pump here. I'm hoping I can very deftly feed in this probe here for it. All right, I'm pretty sure I got it there. Now let's connect the second channel of the scope up there. Okay, and then let's go back to the screen. Okay, turn the car on, and we have our signals here. So there's our cam signal on the bottom, crank signal up top. Both of them look really, really, really good. Let's see if we can find any evidence of dropouts or something to happen here that will explain our code. Right now I'm not seeing anything. So one of the things you can do is I'm going to take a screwdriver right here and I'm going to tap on the cam sensor a bit, and very often this will cause it to drop out if it's faulty. Tapping on it, got nothing. Yep, it looks totally fine actually. So there's a couple techniques that we can do here with this. One of the things, we may need this engine to run for a while and get hot, see if we lose our signal. I'll keep tapping on it and stuff. There's a couple of tricks that you can do here. One of them, we could set up a math channel that will actually detect the dropout. I kind of forgot how to do that. It's been a long time since I've done that. But you can set up a math channel to find dropouts for you if they happen. Another kind of just dirty way of doing it is to just zoom out a whole bunch here And this will generally work if you have some consistent consecutive dropouts. But we can just pull out here, and if we get dropouts, we'll see them easier in this way zoomed out mode here. That might be a little bit much zoomed out. Let's try 50 seconds per division there. And then we've got, I want to say it's like 16 buffers or something of this. So we can run this for quite some time and see if we get some dropouts. While we're doing that, I'm going to tap on the sensor here. All right, there it is, right there, buried under the power steering pump, which is right there, right there. So to replace this, oh wait, look, there was a dropout. Holy cow, I missed it while we were doing all that. See that right there? See that? Right there, there's dropout right there too. We've got dropouts. Okay, so, and whoa, I don't know what's going on with all this, but we got something going on with this cam sensor now. So we were able to catch this on the scope. Good luck doing that with your DVOM. All right, so let's stop this and let's zoom in here. Okay, and let's get back in there. And yeah, look at that. Right now, we're not picking up anything at all. There's one, there's one, there's one. See our dropouts? How cool is that? Wow, there's like a double reading right there or something. Yeah, it is reading very, very inconsistently right now. All right, well, how easy was that? Just gonna make sure this isn't due to a connection issue with my scope or with the connector here. And it is most definitely not. I am connected in real good. All right, problem number one solved. This car needs a camshaft position sensor. All right, now, just gonna make absolutely 100% sure this isn't a power dropout, that this is a signal dropout. There's my power input, never lost the power input. So we have power, we obviously have ground there. Let's get back into our signal here. And there's our signal again. And at some point that's gonna definitely drop out again. Whenever that is, but we proved our point. Okay, so camshaft position sensor for this car. Done with that. Now let's look at the VSS. All right, well, this car's got a little bit of a oil leak here. And then also we've got a bunch of these. Oh, wait a minute. Look at this. Okay, so here's a vehicle speed sensor right here. And if we follow this wiring here, this purple wire right here, there's a butt connector right there. Big flag. Big, big flag there. Let's see here. Yep, there's been some wiring repairs done here. We've got kind of an oil leak right over this wiring. It looks like that butt connector looks like it is intact. The wiring looks intact. So we will have to check that and make sure that we've got signal up to the computer. This may be a wiring issue and not this speed sensor. So I think what we're going to do, take my green probe here, go into this yellow wire right there, and then we're going to attach some wire leads here so I can work from the top of the car much more comfortably. Get the green guy in there. Kind of hard to do holding the camera here. I don't even know why I'm bothering with this. All right, so we've got our probes there. Let's go up to the top of the car. All right, and what I'm using is just this big long wire extender here that just kind of reels in for convenience. And that way I can take my wiring up to the top of the car here. All right, working smarter rather than harder, especially in my delicate condition here. So we are back probed into that vehicle speed sensor. Right now, I'm a little bit concerned that we didn't even get a blip on there. So either we are missing a bias signal or there is no bias signal on this vehicle. I am not sure which the case is. I kind of would expect a bias signal voltage. Maybe there is not one. I will have to look that up if we continue to have difficulties here. I'm going to bring my voltage down maybe to about 2 volts. Is there a 5 volt? Oh, that'll be even better. Okay, so we're going to bring that to 5 volts and we're going to AC couple this because we saw that this is clearly an inductive sensor. So we're going to get a sine wave on this. We know that from our paid channel content on training on Hall effect and inductive sensors for cam, crank, speed sensors, all that. So what we're going to do now is see if we get a speed sensor voltage generated here. And that will give us a clue whether we've got a problem with the sensor or whether this is some kind of wiring problem, which is not unreasonable given that butt connector that we found. All right, start the car up here. Get a little noise on there, that's fine. Put this car into drive and let the wheels spin. And there is no speedometer activity, and you can see that there is no activity from our sensor whatsoever. So, looks like this sensor may be bad. The only other possibility is maybe we're shorted out somewhere, and we're getting that sensor voltage shorted out. So in order to test for that, what I'm going to do is I'm going to disconnect the sensor. Let's go under there and take a look here. All right, so we disconnect the sensor now, and there's our speed sensor right there. So with this disconnected, let me just check for a bias voltage real quick. Let's head back up. All right, I don't see any change at all. Let's put this back to DC here. Nope. There is either no bias voltage or we've got some kind of electrical or computer issue on there. I'm not sure yet. So we need to do one last thing, and that is we need to directly measure from the vehicle speed sensor without the connector connected in case we've got some kind of short out. And let's see if we get a signal now. All right, so what I'm going to do now is we're going to feed a couple of probes right directly onto this speed sensor here. We're going to measure without any potential electrical interference that we may have. All right, so let's see here. It looks like the purple wire on the connector would be on the left, so just to stay consistent, we're going to go red there, and then green on this other connector. And I don't want these to touch. There it is. Okay, and then hang on a second. Slide this insulator up on one of the connectors so that they don't touch. Okay, so now what we're doing is we are measuring directly from the vehicle speed sensor itself, and look and see if we get a sine wave now. All right, start the car, and put it in drive here, let off the brakes, let the wheels spin. Of course, we're disconnected, so we won't see anything anyway on our speedometer. However, look here. We look on our screen, we have a beautiful, beautiful sine wave directly from the sensor. Let's speed up a little bit. As we speed up, we increase amplitude and frequency. This vehicle speed sensor works, folks. How about that? Didn't see that coming, did you? I know I didn't. And aren't we glad we didn't just put a vehicle speed sensor on it based on the code? We wouldn't have fixed this car. So that changes things a little bit. Let's do this real quick. All right, vehicle speed sensor works. So I'm actually underneath the vehicle here right now. Just want to plug this in, make sure this isn't some kind of an intermittent issue or something like our cam sensor is actually. So vehicle speed sensor is plugged in, and we're just back probing it. What I've done now is I've plugged the vehicle speed sensor back in, back probed it. We're going to repeat this test just to make sure this isn't some kind of an intermittent problem like we know we have with our cam sensor. Just want to verify, we know we've got signal from that vehicle speed sensor, no question about it, but it doesn't seem like we have it when it's plugged in for some reason, which indicates some kind of a wiring issue that we're shorting out when it's plugged in. So I just want to run this one more time. Okay, let's put it in drive. And, well, wait a minute. We just got signal there. But it looks like a lot lower voltage than what it should be. But we do have some signal there. Huh. Okay, let's keep an eye on that as I try to play around on these wires here and see if we've got some kind of wire continuity issue. But the speed sensor is somewhat working now. By the way, the speedometer worked as well. Huh. Yeah, it looks like we might possibly have some type of a wiring or communication issue here. So let's see here. With this guy plugged in, let me go over to the wheel again. Okay, so we're going to bring up about 40 miles an hour based on the speedometer, which is working now. It wasn't before. And we see, I want to see if I can get up to about a volt. Okay, so it's about 60 miles an hour to get to a volt. Right about 60 miles an hour for a volt. Now what I want to do, I'm going to go back down here. Really not optimal for my condition here. But we're going to go back down here. Going to disconnect it again. Hang on. Reconnect directly to the sensor again. All right, let's go up top. Okay, well, just there, we've already got a volt just with the wheels spinning. You see the wheels are free spinning here. And we have some kind of electrical problem, I believe, with this system. Not the sensor, though. The sensor is putting out an absolutely gorgeous voltage, but boy, we really seem to lose a lot of it when we connect it, and then it totally gets lost sometimes intermittently. Let me go ahead and turn this off. All right, so we're going to disconnect everything from our VSS. Going to back probe our VSS connector here and go up one more time, look for bias voltage, but also we're going to check this butt connector right here. And this butt connector seems to be stable, so we will probably have to trace this wiring up. Let's see. Yeah, we will have to do some investigation on here, but right now it does not look like this vehicle speed sensor is the culprit. It looks like this is an electrical problem. All right, let's check for bias voltage here again. Yeah, it does not look like we have any bias voltage at all here. Should we, though? I'm not sure. So we'll have to look that up now. All right, we're going to have to look that up. I think what I'm going to do, I'm going to go ahead and plug our speed sensor back in. All right, speed sensor's plugged back in. Get back up to our 2 volts there. And let's get in the car. Let me just check to make sure we're back on AC here. Yep, okay. And then let's go in the car. All right, gonna go ahead and put it in drive. Let go of the brake. Speedometer works again. Speedometer works, however, that signal doesn't look anything like what it should. Nothing like what it should. Cleans up as we get a little more speed. Wow, and now it looks really good. See, now it looks great. Now it looks excellent. This really seems to be a wiring problem for sure, because we know we get a gorgeous signal from the speed sensor itself. That looks very good for just sitting around here with the wheels free spinning at like 8 miles an hour or whatever. It didn't even look like that a few seconds ago. This is definitely some kind of wiring problem. We're gonna have to solve this in another video. All right, well, once again, how many times have we seen this? You cannot just replace parts because a code mentions the part. The vehicle speed sensor is not the problem on this car, that is for sure. So throwing in a vehicle speed sensor would not fix this. I'm kind of happy about this because on a video like this, I'll always get flack from people who would have fixed it in 5 minutes because they would have put in a camshaft position sensor and a vehicle speed sensor and fixed the car. Guess what? You put in a vehicle speed sensor on this car, you will not fix it. And now what are you gonna do? How are you gonna explain that to your customer? Oh, it needed it anyway. No, it actually didn't. You miscalled it, and now they've lost trust in you. And now how are you gonna work this out? Are you going to diagnose it for free? Are you going to give them some kind of discount on the repair? One way or another, in my opinion, you've got to swallow this because you guessed and you made the wrong call. We didn't do that. We know this is probably going to fail again because we saw how intermittent that signal amplitude was getting. I unfortunately am not going to be able to fix it this video because unfortunately the PCM on this car, I am very positive I remember on these like around 2000 era GM cars like this, the PCM is located under the dashboard behind a kick panel, and I am afraid I am just not in condition after my surgery that I can crawl around and access that right now. It's just not going to be possible. So what I am going to do though is I am going to replace that camshaft position sensor. I will replace that squeaking belt, and then we will have to come back later and we will figure out this vehicle speed sensor issue on another video. I think that'll be good. All right, I hope you enjoyed this. I hope you had an amazing, amazing 4th of July weekend here, and we will see you as soon as we can. Thanks for watching.